All right, so I think we're gonna do this in one more little section and then we're gonna be done. It's not gonna take as much. It's not gonna be as long as you think it is. But I'll have to readjust your homework. So when you guys go in to look at your homework, I'll show you your homework. But when you guys go in, it's gonna change. So don't go by what it is right now. It eventually will be assigned. So if you want to go ahead and, I mean, you really can't, but just know that it's going to be there. So if you don't want to submit it yet and you want to wait to submit it tomorrow, that's fine. Okay. All right. So the normal distribution with mean and standard deviation. I want to flip to my paper. Am I on the wrong page? Why is this weird? No, it's not. I'm weird. All right. Approximately 68% of data falls within one standard deviation of the mean. And the figure shows it, but I'm going to draw you another one eventually, okay? I'm going to draw you another one so you can see it. So if you look at this figure, your mean is right in the middle. You have a -1 to +1. That's one standard deviation below. This is one standard deviation above. In between there is approximately 68% of the data. That's what it's telling you, okay? Within two standard deviations is 95%. And then within 3 is 99.7%. Okay. So typically in stats, we're only going to go 3 standard deviations. You can go more. You can go more. But again, approximately 99.7% of the data is going to be within 3 standard deviations, so it's almost pointless to go any further. Okay. All right, so ITBS vocabulary scores using the 68, 95, 99.7 rule. The distribution of ITBS scores for the 7th graders in Indiana, what does this mean? That's the mean and your standard deviation, good. This is the mean. And this is standard deviation. Sorry, y'all. Ms. Huber emailed me. I had to email her back. I apologize. All right. So what percent of the ITBS vocabulary scores are less than 3.74? Show your work. So this is how this is going to work. You actually have to draw your curve. We're going to put our mean. And I'm going to write my values on top. Typically, you write them on the bottom, but I don't want it to squish into that other writing. So on the top, on your mean, it told us was 6.84. You have 1, 2, and 3 standard deviations above and below. And since your standard deviation is 1.55, each time you go up, you'll add 1.55. Each time you move down, you subtract it. So again, if you're looking at this, I'm going to do all the ones above first. We have 6.84. We're going to add our 1.55. So your first standard deviation is going to be at 8.39. I'm going to add 1.55 again. And this one's going to be at 9.94. And the last one after adding will be 11.49. Is everybody okay with how you found that? So then to get the bottom half, you're just going to subtract. So 6.84, and I'll move this in just a second. So if you didn't get those values, they're right there on my calculator though. The next one will be 5.29 because you subtracted. We're going to subtract 1.55 again and get 3.74. And we're going to subtract again and get 2.19. These are your numbers that you need to remember, okay? This bar area is 34%. And that one is 34% because your 68 is split in half. Okay, so remember between the first two standard deviations, -1 and 1, there is 68% about it, data. So on each half, there's approximately 34. The next you're going to have is 13.5. Okay, how do I get that? Just so you know how to find it. We had 100% of the data. We're going to subtract, this is supposed to be 95. That leaves us with 5% left. That's what's going to be on either side of this data. So what is that going to be? If I take 5 and split it into either side? 2.5. And that's as far as we typically go. And that gets us, again, if you do 34 plus 34, that's your 68. Has everybody got that? If I add all of these up, so I'm going to add 13.5 and 13.5, there's my 95.
Where did you get the 13.5 from?
Right there, 100, this right here is supposed to be, I just showed you. This is supposed to be 95% of the data. Clear this out. 95%, but I already used 68. So I have 27% left. I divide that by 2 because it's one on one side, one on the other. Is everybody okay? All right. So it says what percent of ITBS vocabulary scores are less than 3.74? So we're going to find 3.74. Everybody good? 3.74. How much is less? 2.5%. Drawing that curve showed your work. Okay. What percent of scores are between 5.29 and 9.94? So 5.29 and 9.94. How would I get that? So we would have 34 plus 34 plus 13.5, which gives us, that's it. Now, realize that if you draw this curve, this is going to be okay. This would be fine for your final exam or your AP exam. Be careful on this because this 2.5 gives you the full 100%, but we should only be at what? 99.7. So that little bitty extra right here is not accounted for in that 99.7 rule. I have accounted for it in here. If you don't want to do that, remember how you find it. So you had 68 plus 13.5 plus 13.5, and I'm just showing you. I know that that's 95. But you have a 99.7 rule. So what's left over is actually 4.7. And we divide it by 2, this should be 2.35. So if you're getting some weird numbers, not like the book's getting, that's where it's coming from. Because I put 2.5 right there, but they put 2.35. So it would be okay to write 2.5? Yes, as long as you draw your curve out, you're going to be fine. Okay? All right, this rule only applies to normal distributions. Yes. All right. Check your understanding. The distribution of heights of young women ages 18 to 24 is approximately normally distributed with a mean of 64.5 and a standard deviation of 2.5. Sketch a normal density curve for the distribution of young women's heights. Label the points, 1, 2, and 3 standard deviations for the mean. So we're going to go ahead and do that. We make our pretty curve. If it's not pretty, it's okay. You do the best that you can. What's our mean? We're doing 1, 2, 3 standard deviations. And how do we find our other numbers? So 64.5 plus 2.5. 67. It's okay, you can talk. Plus 2.5 is 69.5. Plus 2.5 is 72. We're going to subtract it and get 62, 59.5, and 57. That's it. That's part one, number one. What percent of young women have heights greater than 67 inches? %. So number two, how do we get 16%? Remember, this is 34, 13.5, and 2.5. Sorry, that 5 is over there. I was looking at my watch while it was happening. So add those together, 13.5 and 2.5, and you get 16. Number three, what percent of young women have heights between 62 and 72 inches? How do you get that? 34 plus 34 plus 13.5 plus 2.5, and what do we get? And that's it. That's all you do. So those are really, really easy problems. So when you ask me, does it get harder? No, but you have to remember this. Okay, you have to remember your percentages. I want to do this section and nothing else, okay? So when we get to the next dark bold header, we're done. It's not much, like a couple paragraphs, little picture. All right, all normal distributions share many properties. In fact, all normal distributions are the same if we measure units of size of our standard deviation from the mean as center. Changing these units requires us to standardize. We've already done that. How do we standardize? And my question is, how? What do we do? Observation minus the mean divided by the standard deviation. If the variable we standardize has a normal distribution, then so does the new variable z. This is called the standard normal distribution. I lied to you. I want to do one more. The standard normal distribution is what I want to do. And then I'm done. I do not want to do the table. Tomorrow, make sure that you have the table handy. I do have it up there on your screen or whatever, but it's going to be much better for you to have it. If you're here, bring your books. It's in your books. You don't have to print it off. It's in your books. If you're at home, it's in your book. Okay. So I'll show you where it's at. So just make sure you bring your book if you're coming to class. And if you're here on Zoom, make sure that you have your book handy. You need the table. Okay. So the standard normal distribution, the only difference is instead of having actual values at the bottom, we have 0, 1, 2, and 3, -1, -2, -3. So that's why we standardize, is so that we can make our center at 0 and our standard deviation of 1. Okay, our mean is 0, standard deviation 1. So you guys were asking me, why do we want it 0? Why do we want it 1? This is why. It's because we want to standardize it so that we can compare it to other sets of data. It doesn't matter. We can compare apples to oranges as long as we standardize. Does that make sense? Okay. So here's your curve. Your mean is at 0 and your standard deviation is at 1. And if you can see them, I know it's hard to see. This is 0, 1, 2, 3, -1, -2, -3. All that stands for is your mean is at 0. You can be 1 standard deviation above, or the -1 means 1 standard deviation below the mean, okay? If a variable x has any normal distribution, remember we labeled that in with our mean and our standard deviation, with a mean and standard deviation, then the standardized variable is going to be z equals the observation minus the mean over the standard deviation, which then turns this normal distribution into a mean of 0 and a standard deviation of 1. Tomorrow, we'll work with this standard curve to find our z-scores. Your z-scores are also in table A, which is what it's going to talk about next. Please, please, please bring your book. I'll modify your assignment. I'll tell you which ones you need to do. I'll send you a message, okay? So if you're good, you can go ahead